Namaskar friends, welcome to session 20 in our course on operations management, and currently we are in week 4 of our discussion on the course, and we have already finished our discussion for the first 3 weeks. In week 1, we have covered the basic aspects of operations management, scopes and functions of operations management. In week 2, we covered the product design and development, in which we have covered the basic concepts of design for manufacturing, design for assembly. We have covered value engineering, we have covered rapid prototyping, we have covered the basic aspects of ergonomics. In week 3, we have covered sales forecasting, in which we have covered the qualitative and quantitative methods of sales forecasting, and now we are in week 4, we are discussing the plant location and how to decide that where we have to set up our plant. This is a brief summary of the course till today, and in this particular week we are now into the end of our discussion on plant location, and this is the 5th session in week 4. And in 4th week we have covered the basics of plant location and layout in session 1. In session 2 we covered the factors governing the plant, facility location or the location, and then we have seen the case study of the state of Uttarakhand, that how Uttarakhand is promoting the industries. And in the 4th session we have covered the quantitative method, that is location evaluation methods 1, and now today we are going to cover the location evaluation methods 2. In location evaluation method 1, we have covered 2 methods. The first one was the cost volume analysis, in which 3 inputs were required. The fixed cost was required for a particular location, the variable cost for a particular location, and then we required the volume of output or the production expected from that particular location. Based on that, we plotted a curve, or we plotted the data on XY plot. X-axis was showing the volume of production or the output, annual output, and on Y-axis we have plotted the total cost, and from there we tried to figure out that which location can give us the best results in terms of the minimizing the overall cost or the total cost of production. And the second method that we have seen in the previous session was the factor rating method, in which we have seen that first we have to identify the list of factors that are going to govern our decision related to the selection of location, and then we give certain ratings to these factors on a scale of 0 to 10 or 0 to 100, and finally we multiply the weights assigned to these factors with the values or the rating that is assigned to the factors for each particular location, and then we multiply the weights and the scores and add up the scores for each location, and then we compare the scores and try to select the best location for setting up of our plant. So this is what we have covered in week 4 related to plant location, and today we will try to wind up, we will try to finish our discussion on plant location with 2 more methods that will help us to decide that where we have to set up our plant or facility. In next week our discussion will start on plant layout, and once we know that where the location of our plant is going to be, then within that location where which facility must be created. For example, like IIT Roorkee, we have specific areas for specific facilities. Maybe there is a specific location for hospital, specific location for hostels, specific academic area. So within this location we have the layout of the various facilities. So from plant location and layout we try to understand that when we are trying to manufacture something, we have to identify where our factory is going to be located. So from starting from the country to the state to the district to the town, we have to zero down on a location where the facility has to be created, and for that these are the tools and techniques that we are discussing in this week, which help us to make a judicious decision regarding the setting up of this facility. And we have already covered 2 methods or 2 quantitative methods in session 4, and today we will cover two more methods which will help us to make this decision. But as I have told in the previous session also, it is not only the mathematical values that will be used for making the decision. We will definitely take into account the other factors which we have already considered in our session 1 and session 2, and a combination of these two, the qualitative and the quantitative information, will be used for finalizing the location. But currently today our focus has to be on the location evaluation methods, and today we are going to understand two more methods which will mathematically help us to calculate the scores for different locations, and these scores in the meanwhile will be helping us to take a informed decision about the location of a facility. The third method that we are going to cover in quantitative methods for identifying of locations or plant location is the center of gravity method. Now, here the decision is based on the minimum distribution costs. So, if you remember the previous two methods that we have seen, we have in the first method, that was cost volume analysis method, what was our input? Our input was fixed cost, variable cost, volume of production. So, that method was based on the fixed and the variable cost, or in nutshell we must say the total cost and the volume of production. Now, the second method that we covered was the factor rating method, that was based on the weights assigned to each factor and the rating given to each location based on those factors. And the third method that we are covering is the center of gravity method. It is based on the minimum distribution cost. So, we will try to reduce the cost of distribution first. So, what is the objective of this method? We are trying to find out a location of a single facility serving several destinations. So, basically we are trying to figure out one particular central manufacturing facility which can cater to a number of demand centers. So, we can have 8 to 10 demand centers, but we have only one manufacturing facility from where we have to satisfy all these demand centers. So, this is used for services and distribution centers. As you are well aware that while distributing or while identifying the logistics for managing the supply chain, usually the companies try to locate a central warehouse at a position from where they are able to serve a number of maybe regional centers or a number of state centers. So, basically that location of that warehouse for distributing the product to various demand centers is very critical, and it is based on minimization of the distribution cost. Now, how to figure out that where this warehouse or where this manufacturing facility may be created, that is going to be found out using the center of gravity method. Now, it requires, now what are the inputs? For each and every method, we are trying to find out that what is the input required. Now, input here required is the location of the existing destinations. So, we need to find out that what are the demand centers, and the demand centers here we are calling as the markets or the retailers. So, why we need to find out that what are the demand centers that we are trying to serve, that this facility is going to serve or this manufacturing facility is going to cater to. So, that is one thing, we require their location. Second is the volume or the quantity to be shipped is another input requirement. Finally, the shipping distance or maybe in some cases the cost is very important. So, we require the destinations, we require the volume to be shipped to each destination, and finally we require the shipping cost or distance. So, maybe sometimes we may try to optimize or minimize the distance that maybe the material or the product has to travel from the source to the destination. Now, the center of gravity method is based on finding out the x and y coordinates for all the destinations or for the final destination of our facility. So, our main objective is to find out the xy coordinates of the facility that we want to create. But for that, as we have already seen, it is prerequisite that we know the x and y coordinates of all the destinations that are going to be served by this facility that we are creating centrally. So, can use an arbitrary coordinate grid, calculate center of gravity location for facility as weighted average of x and y coordinates. So, that we will try to understand with the help of an example, that how we calculate, how we give the maybe final coordinates of the location. It minimizes the transportation cost approximately. Approximately means the solution is an approximate solution. It may not exactly be fitting into an exact solution, but the solution that we get, because it may so happen that mathematically we are calculating xy coordinate, but the xy coordinate that we are getting may not be feasible from other standpoint, that it may be located in the hills or maybe a region which is inhabited. So, we cannot, maybe which is inhabitable maybe. So, we can say that no, that facility cannot be created there. So, we have to look for some other location nearby where we can locate this facility or locate this manufacturing facility. So, the actual ideal solution is pointing out at a particular xy coordinate, but we are not able to acquire or set up the facility. So, we are setting up at a nearby or in a best possible location nearby to the ideal xy coordinate. Therefore, we have tried to add the word approximately. Now, location is not necessarily optimal, but it is usually close to the ideal scenario. So, let us try to take an example. Center of gravity method, we will do the calculations based on these two formulas as given here. So, x coordinate for our facility will be calculated as Cx and y coordinate as Cy. Now, Cx how we will calculate? As we know, what are the two inputs required here? The two inputs required here are the x and y coordinates of the destinations. So, Dix here is the x coordinate of location I, and Wi is the volume of goods moved to or from location I. So, this is the first thing. In the numerator, we require the x coordinate of location I. Now, we can say we can have 5 or 6 or 7 or 8 different locations. So, I can go from 1 to maybe 8. So, this is the x coordinate of location I. Similarly, Wi is the volume shipped that we have already seen. Let me go to the previous slide again and maybe this slide. So, what are the requirements here? So, you can see the requirements. We require the location of existing destinations. Now, existing destinations locations means we need their x and y coordinates, and we require the volume to be shipped. Now, here Wi is the volume or the quantity to be shipped, and sigma Wi is the total quantity that we are shipping from our manufacturing facility. So, this data will give us the x coordinate for our final destination or final objective. So, first we require the x coordinate of each location which is to be served by this manufacturing facility. We require the volume to be shipped to that particular destination, that is destination I. Suppose we call our manufacturing facility as M. So, how much volume we need to shift from M to I, that is location 1, that volume is known to us. Then how much volume of product we want to ship from M to location J, that must also be known. How much volume we want to shift from M to location Z, that also must be known to us. So, from this central location where we want to set up our facility, how much volume we are shipping or we are sending to different locations, that must be known to us, as well as we must know the xy coordinates of location I, xy coordinates of location Z, xy coordinates of location X. So, all that must be known to us. So, here we can see once we know this data, we can very easily calculate the x coordinate of our objective The objective is to locate a facility where we want to establish our warehouse or where we want to establish our manufacturing plant. So x coordinate can be calculated using this equation. Similarly, y coordinate can also be calculated. Only thing that will change in y coordinate is that we have to use the y coordinate of our destinations. As I have taken an example of 3 different destinations, we need to have the y coordinate of all the 3 different destinations, and then we can, based on that, we can calculate the y coordinate of our manufacturing facility. The volume, as I have already told, as in calculation of x coordinate, we require the volume of products to be shipped to the various destinations from this facility that we are trying to create. Now, I think some of the learners may be little bit confused what I have explained till now. Although I have tried to be very simple in giving my explanation, but I think the things will become crystal clear if we see this example. If we are attentive and if we focus on this example, the things will become absolutely clear. Now you can see we have taken an example where 4 cities, there are 4 cities maybe in US, Chicago, Pittsburgh, New York and Atlanta. So 4 cities with the volume of demand and XY coordinates are given. The volume of demand you can see here is given. Chicago has a volume 200 requirement, Pittsburgh 100, New York 100, Atlanta 2000, and on a XY scale all the 4 coordinates are given. The blue circles or ovals that we have on the screen are representing the locations. So we can see Chicago, x is 30, x coordinate is 30 and y coordinate is 120. Similarly, Pittsburgh, x coordinate is 90 and the y coordinate is 110. So we have the x and y coordinates for all the 4 locations. Now find the location for a warehouse minimizing the total distance to supply these cities. So we have to minimize the total distance here. We are not focusing on the cost involved here. So we are seeing that our objective is to minimize the total distance and find out the optimal location which will minimize this total distance in order to supply to these 4 cities. Now how we will calculate? So what is our final answer going to be? The final answer going to be is the x and y coordinates of that location which will minimize the total distance to be travelled for serving these 4 different destinations. Now how we will do the calculation? We can see x coordinate for Chicago is 30, y coordinate is 120. Here we can see Chicago, x coordinate 30, y coordinate 120. Similarly, Pittsburgh, New York and Atlanta, x and y coordinates are known to us, volume also is given to us. So x coordinate of the warehouse or the manufacturing facility can be very easily calculated in the equation, as we have seen that we have to multiply the x coordinate with the volume. Similarly, and this has to be a summation has to be done for all the 4 locations. Here we can see again that I is the location, here and summation I. So in our case we have 4 locations, so we say I goes from 1 to 4, and here also we will add the demand for all the 4 locations. So here 200 is the demand and it is multiplied by the x coordinate, plus then x coordinate for Pittsburgh is 90, the demand is 100, then the x coordinate for New York is 130, demand is 100, similarly 60 and 200, and then it is divided by the overall demand. So overall demand is 200 plus 100 plus 100 plus 200, so it comes out to be 600. So then we get the x coordinate of our warehouse or the manufacturing plant. Similarly, we can calculate the y coordinate. Here the y coordinate will be multiplied by the volume. So 120 into 200, 120 into 200, 110 into 100, 110 into 100, and then summation divided by the overall demand. So the overall demand is again the same and we get the y coordinate. So we can plot this x and y coordinate on XY scale and try to find out that whether this is going to give us the minimum distance that is our objective. So, here you can see when we plot this 67.7 and 93.3, this is the location. So, this is the location which will optimize or minimize the distance travelled from one place to another. Now, the next method that we are going to use is the transportation model. So, we are not going to solve any problem using the transportation model, but we are going to find out that what are the different methods that can be used to solve this type of a problem. If you remember, in the previous method that we have seen, it was one source only. We have located one warehouse or one manufacturing plant from where we are serving 4 different demand centers or 4 different destinations. So, one source, 4 destinations. The problem was solved for minimizing the distance to be covered by finding out the x and y coordinates of our warehouse. But in many situations, in many multinational companies, we may have a different problem. We may have 3 or 4 sources, 5 or 6 destinations, and then we have to find out the optimal location of these sources that they are able to serve the destinations with minimum possible cost. So, here we can see on your screen there are 3 supply centers or 3 manufacturing facilities S, S and S, and there are 4 demand centers. This is one demand center, another demand center, third and the fourth. So, here we try to use the transportation model that is usually taught in the course on operations research, as I have already highlighted this point maybe in today's session or in the beginning of the previous session. So, basically we try to figure out that what can be the most optimal solution to this transportation problem for minimizing the overall cost. So, we can see that what are the inputs required for solving the problem using transportation model. The requirements here are list of origins and each one's capacity. Now, origins are the sources or the manufacturing plants which are producing the product. We must know that what are the locations from where we are going to serve the various demand centers. So, we need to identify their locations, maybe again x and y coordinates are required. Similarly, we must know what is the capacity, what is the production maybe capability of a particular source. That is one input that is required for solving a problem. Second input is the list of destinations. We must know that what are the various demand points that have to be served by these sources or these manufacturing plants. So, we need to identify the manufacturing plants, we need to identify the markets or the demand centers, and location of each one of these as x and y coordinates must be known to us. Then we must know that what is the demand of each destination. So, that we must know the capability and the demand. Otherwise, what can happen? There can be a mismatch. So, we need to know what is the total availability of products at the various sources, what is the overall demand at the various demand centers. So, these are the 2 things that are required to solve this transportation problem. And then the third thing that we must know is the unit cost of shipping, and which has to remain constant. So, if we are changing the unit cost of shipping for each demand and each destination, each demand and each source, that from source A to destination B the shipping cost is suppose 1, and from source B to destination suppose D the cost is 2, or maybe if the cost is changing, then the problem becomes very complicated. So usually it is advisable that when we are solving a problem using transportation model, the cost must remain constant between the various sources and the destination, because that is the basic basic objective of our decision making. The solution is found out which minimizes the total cost of this problem. So, as I have already told, the transportation model is based on certain assumptions. As one of the assumptions I have already highlighted, that is the shipping cost per unit is the same, that we have to ensure, and secondly the items to be shipped are homogeneous, similar type of items, and only one route is available between the origin and the destination. So, we cannot have multiple routes between one origin and one destination, only one route is there between the origin and the destination. Now, the transportation model is based on this is a generic transportation model that we are trying to understand today. We can have a specific transportation model also, like here in generic model we have m number of sources, m number of factories, I can say, n number of destination, maybe n number of warehouses from where the warehouses where the product is going after being manufactured in the manufacturing facilities or manufacturing plants. So, we have m number of manufacturing plants, we have n number of warehouses, we have AI as the supply at source I, then Bj is the demand at destination J. So, now Bj is the demand at destination J. Now, suppose J can go from 1 to 5. So, we can have 5 destinations, and supply at source I means that we can have 4 sources. So, it can go from I goes from 1 to 4, J can go from 1 to 5. So, we have 5 destinations, 4 sources as a specific transportation problem. Then we have Cij, cost of transportation per unit from source I to destination J. So, we require the cost data for each transportation from source I to source J, and Xij is the number of units to be transported from the source I to destination J. Now, you can see that with this generic problem we can convert to a specific problem, and then we can solve it using the various methods that have been used by various researchers and scientists as well as engineers in solving these type of problems. Now, transportation problem maybe can be summarized in a way that we require that how many sources are there or how many factories are there, how many demand centers or warehouses are there. Then we need to understand that what is the demand at each warehouse or demand center, what is the capability of each source, what is the unit cost of shipping from each source to each destination. So, all this data can be clubbed and put into a tabular form like this. So, we can have sources as we can have generic 1 to m sources, then we can have number of destinations from 1 to n, then we have supply AI as we have seen that what is the capability of each source, and B1 is the demand at each destination. So, we can fill these values, and finally the problem can be solved using number of different techniques. To name some of them, row minima method is one, column minima method is another technique, least cost method, Vogel's approximation method is there, the northwest corner method is there. So, there are number of methods. Because of the paucity of time, we are not covering in detail, because we had 5 sessions of half an hour each for this maybe topic of plant location, and today we are winding up this week's discussion. So, I will advise each one of you, each of the learners, to at least learn one method of out of these 4-5 methods and try to solve a problem using the transportation model for finding out the best location for our manufacturing facility. So, with this I conclude today's session as well as the discussion for this week on plant location. In next week, our discussion will be on the plant layout, and we will try to see that what are the different types of plant layout, what are the different types of sequence or the flow diagrams, and how or what type of layout can be used for which type of manufacturing activity. Thank you.